solid sphere is rolling on a horizontal plane without slipping, if the ratio of angular momentum of what axis of rotation of the sphere to total energy of moving sphere is pi is to 22, the value of its angular speed will be dash rad per second. So in the question we are given ratio of angular momentum L to the total energy, that is L by E. So both of these values we have to find first. So we know angular momentum formula is I omega, and we know for a sphere, for a solid sphere, the moment of inertia is equal to 2 by 5 mr square. So our L will be equal to 2 by 5 mr square omega. Now we have to find the total energy. We know for a total energy for pure rolling is the sum of both translational and rotational energy. So we have energy E is equal to half mv square plus half I omega square, and we know the I is already 2 by 5 mr square omega square, and we know for pure rolling motion V is equal to omega r. Now if there is anything to cancel, we can cancel. So instead of V we can write omega r. So we have half m omega r whole square plus 1 by 5 m omega r whole square. Now we can take m omega r whole square common, and we'll get 1 by 2 plus 1 by 5, which is equal to 7 by 10 m omega square r square. Now we have to take the ratio L by E, which is equal to 2 by 5 mr square omega by 7 by 10 m omega square r square. Now we can cancel omega square, r square, omega square and omega in the denominator, and 5 and 10 will get 2, which we can write as 4 by 7 omega. And we're also given that this answer is equal to pi by 22, which is given in the question. So here we have equal to pi by 22. We know pi value is 22 by 7, so we have 4 by 7 omega is equal to 22 by 7 into 22. Cancel 22 over here, 7 and 7 into both sides. And now we can take omega to the other side, so it will be omega is equal to 4 rad per second, which is our answer.